Welcome to the introduction to Docker. We'll be talking a lot about Docker. Containers have obviously been very big in the past few years, and even more so going forward, we'll see a huge migration of things running in a virtual machine, migrating into running into multiple containers. And this is the way most applications, server applications, are moving towards. But to really understand how containers work, we need to first understand how virtualization works. So most of us are familiar with virtualization of one form or another. In data centers, by far, the VMware is the dominant in most commercial data centers. However, Linux KVM, Linux Kernel Virtual Machine, is rapidly gaining traction in a lot of spaces, as well as Hyper-V by Microsoft. The reason being is VMware has significantly more features than their competitors, but people really just want the basics. What do they want in their data center with virtualization? Well, they want virtualization, being able to run multiple servers on a single physical box. They want vMotion, the ability to move one of those virtual servers from one physical host to another physical host without having to shut it down. And they want high availability. If a virtual machine or a physical server fails, they want the virtual machines that were running on that physical server to automatically start somewhere else. And so we've really seen kind of a leveling of the play field. Why did VMware get such a start in this? Well, it comes down, people think VMware invented virtualization. No, virtualization was around for a long time before VMware. What VMware did do was virtualize the Intel x86 platform, the x86 processor, and patented the bejesus out of it. And so it made it very difficult for people to enter the market with those patents in place. So first patents came out like in 98, the product came out in 99, and it was huge. The virtualization of being able to run multiple operating systems on a single box was massive, but really something called vMotion was really important because I could move a running virtual machine from one host to another. Say, for example, I needed to go ahead and upgrade the memory in a server. Well, in the old days, I would have to schedule downtime, right? With virtualization, I could simply take the virtual machines that are running in the server that needs maintenance, move them to a server that is running, and take all the virtual machines off the one that needs maintenance, all right, without stopping those machines, do the maintenance, bring the server back up, and move the workload back. That was really huge. And so VMware became, super dominant. But let's talk about virtualization. What are we virtualizing? We're virtualizing the hardware. And that's kind of an important thing to remember is this is hardware virtualization. Every virtual machine thinks it has its own hardware, right? So each of these guest operating systems think they have their own hardware. And so they go ahead, they have virtual drivers to talk to the network, to the storage, to the compute. All these things are virtualized. And so we're virtualizing the x86 platform. This allows us to run all kinds of operating systems, right? I can run Windows, Linux, any x86 operating system that is out there, I can go ahead and I can run on it. And so this was kind of cool. But when you think about it, every virtual machine, every time, say we want to run a server with some applications on it, when we spin up a virtual machine, we have to spin up the guest operating system for that virtual machine. So as you imagine, say I wanted to run 50 separate web servers. Well, what would I have to do? Create 50 virtual machines, install a guest operating system on each of those 50. So if I'm doing Linux and I have 50 virtual machines to run this application, that means the Linux operating system is running 50 times. All right, not very efficient, and we'll see if we have some solutions to that. So what's some of the big things here? Remember at this time what was happening is when virtualization really became popular is the CPUs were getting super duper powerful, all right? We had multi-threaded CPUs, lots of different cores, all this kind of cool stuff, and more memory. And so we had a lot of physical servers that were only using a small percentage of their resources. With virtualization, they could now put multiple workloads on that same physical server and made it much more efficient. Really helped us to reduce capital cost, buying the hardware, and operating costs because it's easier to manage virtual environments. We already talked about the maintenance, failover, all that stuff was so much easier with these portable workloads. And the big thing, of course, is it saved money. All right. What were some of the disadvantages? Well, there are some disadvantages to this as well. Oversubscription can be a disadvantage. What do? Well, say, for example, I have, a 100 gigs of RAM. All right, I have 100 gigs of RAM, and I create virtual machines, all right, that take up 25 gig. Well, I might go ahead and create 5 of those. So in other words, I'm saying, hey, listen, these 5 virtual machines are going to use 125 gig, even though the physical machine only has 100 gig. And what that's doing and what we're trying to do, there's oversubscription. Why? Because it's unlikely that all 5 virtual machines are going to need all 25 gig at once. All right. But we had ways to control it with ways we could limit our resources. We could do limits, we could do shares, we could do reservations. There's lots of cool ways. So that was something. Do they run as fast as being on bare metal? No, the operating system doesn't run that fast because we're going through an abstraction layer. All right. You'll see the percentages debated out there. Typical numbers I see around 4 or 5%. Boot up time, well, every time you want to start an application in a new virtual machine, you have to go ahead and you have to launch the operating system. Just think about it. If you wanted to run Notepad, right, on your laptop, what do you have to do? Well, you have to turn on your laptop, wait for it to boot up, and then double click. Actually, starting Notepad doesn't take long. It's going through that power on self-test and booting the operating system takes a while. And the other kind of challenge we have with virtual machines is if I have 50 identical virtual machines, they each have their own hard drive, right? They each take up, if each of them takes up 5 gigs of disk space, that's going to go ahead and multiply by the number of virtual machines. Containers address a lot of these, all right? So when we think about a container, what are we abstracting? We're abstracting the kernel of the operating system, that Linux operating system kernel, all right? So instead of being hardware virtualization, this is operating system virtualization. And so we load up that kernel once, that operating system once, and then the containers share that operating system kernel, all right? And so basically that kernel is running all the time, so we go to start an application, it's very fast because we're abstracting here, right, at this operating system level. And so when I go to spin up an application, it's like you already had your Windows machine running and you double click on the application. You have to wait for that operating system to boot. So we'll see that containers come online much, much faster. Now the very first time you run a container, if it's not locally on that hard disk, you're going to need, of course, to go ahead and get the container. And so that will be part of the process. But let's think about this. If I want to run 50 web servers and 50 containers, how many times is that Linux kernel loaded? Just once. Huge advantage. And so what we'll see is environments like that, oftentimes a server can run 10 times as many containers as it can if they were virtual machines. So containers have been around for a very long time, or at least the concept of them. If we go way back in 1979, Unix, there was something called chroot, which allowed us to go ahead and kind of create isolated disk space for different processes. That eventually got added to BSD, and then decades later, around 2000, something called jails came out. This was FreeBSD jails. And this was a big deal because it isolated file system using and networking. So that means each jail could have its own networking, and that was huge, right? Well, Solaris containers came out about 4 years later, and this came out for x86 as well as the Spark, those of you old enough to remember the Spark boxes. And so this was kind of neat, and they had different types of zones that they're able to go ahead and create isolation and create kind of these containers. But really, there was a couple of things between those two that aren't on the screen here, which is they had control groups came out in Linux. And so with control groups or C groups, this allowed us to go ahead and really create and control some of the resources in there. And then around 2008, Linux containers came out, LXC. But it was really in 2013 Docker. So Docker is the most popular one out there, right? This is the most widely used container management system currently. And so this was huge. It was a very efficient way to deploy applications, right, to have different types of model, to have this whole different types of registries for containers. And we'll get into that. Had a nice API, easy to use CLI, and even later on, we were able to manage clusters of Docker servers. There's a couple others that should be mentioned here. Rocket. Rocket was basically introduced to address some of the shortcomings of Docker, particularly on the security side. And so basically, we go ahead and in addition, they have a lot of rigorous security and requirements than Docker. So it's a little bit more hardcore than Docker. LXD came out with Canonical, and it's another thing. It's more like virtual machines, all right, and kind of give that virtual machine look and feel, but it's with containers. And of course, Windows. Windows 2016, 2019, as well as even certain versions of Windows 10, have Windows containers. So Microsoft started adding containers to their operating system, and it runs great, or it's very cool. And so you can go ahead with this, and you'd be able to go ahead. There's ways to run Docker containers on Windows machines, which is very cool, as well as Windows' own specification for containers. And the idea, of course, especially with things like Azure, is to be able to migrate that Windows workload from your desktop to your data center to the cloud. So let's think of some of the advantages. Containers have a number of advantages, or we wouldn't be talking about them. And so first of all, consistency. It's very frustrating, especially for a developer. They'll create an application and it runs on their desktop, but when they go to run in the data center, it doesn't run. It's missing some dependency, it's missing some resources. Well, the environmental consistency is huge here, right? So we get consistent. It's going to run everywhere because it includes all the resources necessary to run. They're also very efficient because we're not running tons of instances of the operating system. So it allows us to go ahead, and it's very easy to scale containers. They boot up fast, all right? And we're going to see, you can go ahead and you can easily increase and decrease the number of containers based on the need. We start looking productivity-wise. We take these big, massive applications, we break them down into smaller applications. And then finally, we have some version control. The version control here is very cool. It makes it easy not only to deploy new versions, but even to roll back to old versions. And we have some very kind of cool rolling updates that we can do in the container world. So Docker is exciting. It is definitely going to become part of your life if you're a network engineer or a developer. You will be using containers. And so just kind of keep an eye out as you see new technologies of all like AI and stuff like that. It's all container based, right? All the new stuff is being container based. So this is our introduction into our Docker environment. Understand the value of Docker and containerization, we really need to understand application architecture. This is really key. When we think of a traditional environment, we start thinking of a traditional legacy environment, we're like, okay, what do we have? We have a great big application that's grown over time, has many components. Oftentimes, we'll have this running inside of a single virtual machine, right? So this might be in a big VM, and then what we want to do is we want to take that one big application and we want to think about what we can do. There are ways that you can go ahead and just kind of move that big application into containers without breaking it up, but that's really not what we want to do. They call that kind of lift and shift, where you go through and you kind of just take the big application, you move it into container land, still as a big application. That's not really containerization, all right? You're basically treating the container like a VM. What we prefer to do is do a refactoring. We go through and we look at this big application and we find the logical components. What are the individual components? And we break those down into individual services, all right? And so we go kind of through this refactoring process, and then we take these components and we create microservices. Each microservice runs in its own separate container, all right? Or, of course, you could just develop a brand new application, right, that's native to containers. But a lot of times this is really helpful because now you have manageable sizes. These microservices are more manageable and much more easy to test, to create automated testing so that we can move into a microservices environment with the idea down the road of moving to what we call a CI/CD. CI/CD in DevOps lingo is continuous integration and continuous deployment. So when we want to go ahead and we want to update one of these microservices, that's not that big a deal. We simply go ahead, we update just that and we roll out just that microservice. It makes it very easy for us to update, to do rollouts, to do rollbacks, okay? And it makes the development process run significantly smoother than in the traditional monolithic. So monolithic's been around for a long time. As far as development time, it's easiest, right? Because all the individual components automatically can talk to each other very easily because they're in the same virtual machine. They're in the same monolithic, all right? So very easy to kind of get things up and running. And what if you want to go ahead and scale up? You could have multiple copies, or oftentimes we just make bigger and bigger virtual machines. The downside, huge code bases. Everything's in one code base that needs to be managed. Scaling is hard to do efficiently. You know, if just the business logic component is the part that needs scaled, how do you do that? Well, in a monolithic architecture, you have to scale everything, right? Everything scales up and down together. And so it creates some challenges here, and it makes it difficult to go ahead and move towards a CI/CD where you can go do these small rapid updates and be able to roll them out very quickly. When we move from that kind of monolithic environment to this more distributed, all right, we get a lot of benefits. So when we started thinking about this, we have these microservices. They're going to need to communicate with each other. Deployment is really easy, all right? That's really one of the things here is Docker. And Docker was built around the idea of deploying applications. We had some other container systems before it, but a big part of why Docker became so popular is it's very easy to deploy this. And in this environment, it's very easy to understand what's going on. Oh, this container sends this to this container, and you can really see how things work, all right? And a lot of times, these microservices become reusable from one application to another application. So it's like, oh yeah, hey, we need the one that goes and looks up the stock price and compares it with this. Well, if you have these repackageable containers, one of the things that's always harped on with programmers is reuse. Create your code so it's reusable. Containers are the ultimate, right? They're reusable services, reusable microservices. If we have a problem with something, it's easy to isolate what the problem is. Oh yeah, the problem's occurring. Well, this container takes care of this function, so we know exactly, and we can fix it. And it's really powerful for us. Downside, it's a little more complex, right? We're going to go ahead, we'll break these into components. They're going to have to communicate with each other. There are more points of failure, but we actually have a very high redundancy because if a container fails, we can automatically spin another one up, or we have multiple instances of the same container, all right? And underneath is a little more complex for the infrastructure people. But in the end, you end up with a more powerful, more scalable application. You know, hey, I need more business logic power. I can go ahead and just roll out some more business logic containers. And, you know, they're very movable. We can migrate them. So let's think about, you know, when we're doing this, we start thinking about how do we migrate in this environment. And so we call this microservices, microservice architecture, whatever you want to go ahead and call this. But basically we have a few different things. We're going to take these things, these individual components, all right, and they need to be able to talk to each other. So basically we go ahead, each of these are very easy to maintain and testable. That's key. We need to be able to test these to make sure when we do a code update, everything is still functioning, okay? We can deploy these things independently. We can replace them, all right? We can scale them up. Each of these microservices are small, and they tend to be managed by a small team. You know, it might be a giant application, but each of these containers, usually there's only a few people we need to manage a container because it's a microservice, okay? It allows us to update this, automate it, and be able to roll it out very easily. Now, one thing we're going to find about containers is they're a little bit different than virtual machines. Virtual machines have local storage that can contain important data. Containers will always store the important data outside of the container. And this leads us to a common analogy. It's the pets versus cattle, or, you know, pets versus chickens. Depends how you want to go and teach it, whether you like cattle or not, I guess. Anyways, when we started thinking about VMs, we treat virtual machines a lot like pets. Manage them in a small number, they're relatively easy to take care of. If any, we give them nice names here. This is Database Server 1. This is, Luke Skywalker 7. Whatever you want to call them, you give them nice names. You take care of them. If something goes wrong, we patch them and we fix them. All right. And if we want we need more power from it, we make the virtual machine bigger. All right. So we go ahead and we scale them, we make them bigger. And this is very different than containers. When we think about containers, imagine you're raising, 1,000 cattle, and one of those cattle gets sick. What do? Well, you get rid of that cattle and you get another cattle, right? You get another cattle, get rid of that one, you get another one, all right? How do you identify them? You just put little tags, maybe a tag on there. Somehow you just give a basic identifier, all right? They're so equal to each other, you have no special attachment. And basically, if you want to go ahead and get more meat, what do? You buy more cows. And so we treat our containers like cattle. They're not important, individually important. They come, they go, something gets wrong with them, we get rid of it, and we get another container in that place. All right. And part of that magic being able to do that is the separation of storage, but it's very different than VMs. We consider VMs to be persistent, right? We expect that that same exact VM will exist a year from now. With containers, they do not, right? Containers are going to come, they're going to go, and if something's wrong, we get rid of it and we get another one. So these individual components, very replaceable, right? And very easy. And we compare this, there's kind of comparing this to making a big meal, monolithic, where it's one great big meal, as opposed to microservice. We have all these little components, and we can change and fix and update the little components, and it's so much easier to update a big component than redoing everything at once. And this starts bringing us back circle, this idea of microservices. Okay. I like the bottom here. Monolithics plus scaling is sadness. It is, because you scale up everything. If somebody says they want more meatballs, they can't get just more meatballs. They get a whole new plate. They can just make a bigger plate of everything. With microservices, hey, I want more of the yellow donuts. I want more of the blue donuts. You get more of the yellow or blue donuts, right? And so it scales very nicely. Compute-wise, we've moved. We talked about this before. We kind of migrated. And as we migrate from the virtual machine world into our container world, all right, when we go through and we start deploying all these containers, we'll find that one VM might become 10 containers. And so that's kind of one of the challenges as people start to migrate here, is as they go from a monolithic application, say you have a big application and it's running 16 different processes or 16 different services. Well, when we convert that and we migrate that out, we refactor it into a container environment, each of those services might become a separate container. And sometimes we might have more than one container. So we might come out of that with 16 types of containers, always running at least one copy, but some of them we might be running 4 or 5 copies of. And so one virtual machine can become a lot of containers. And that's part of when we start designing and building and figuring out how do we manage these things. Right? Because they're going to have a lot more devices that are going to communicate with each other. We have a lot more entities that are going to communicate. So like I said, you might have 10 virtual machines that might turn into 100 containers when all is said and done. And so we want to understand, how do we migrate? And then once we have these containers, what do we do with them? How do we use them? And finally, of course, how do we deploy and grow and scale them? So this is the section on microservices. Thank you very much. Welcome to the Docker overview. In this section, we're going to take a look at, hey, what is Docker? More of what are the components? Get a little more deeply into what Docker is and how we can use it. So obviously, this is a super popular open source project. It's based on LXC. It's based on Linux containers. Underneath, it's written in the Go programming language. All right. And was actually developed by a company called .cloud, which is Docker. But basically, it's a container engine that uses a lot of cool features of Linux to be able to do deployments. And we talked about things like that, like namespaces and control groups, to be able to go ahead and get that abstraction layer. Makes it very easy and lightweight for us to be able to deploy these, and it's super fast. And so it's going to be a great environment for deploying our applications. All right, be able to separate our applications from our infrastructure. We actually have a portable workload. If you've ever tried to move a workload from VMware to Hyper-V to Amazon, it can be very challenging. Containers make it easy to move this. Makes it easy to ship, easy to test, easy to deploy. All right, and lots of cloud providers support Docker. Also, a lot of support out there for a Docker orchestration tool called Kubernetes, as well as a few others. it does a few things for us. We go ahead and we start taking a look at this as we're like, okay, great. We're going to start off defining an image format. Hey, how do we store and define a container? And so we'll be taking a look at methods for building, look at Docker files. Docker files are how we deploy and create containers. We need a way to manage these. We need a way to share. We need a way to run. We need to be able to do all these things. Now, a lot of people work together, especially on getting some of this standardization, on something called the Open Container Initiative, or OCI. And so basically they went ahead and come up with a kind of a standardized way to be able to standardize containers and using something called runc. But basically you'll hear about Docker images, you'll hear about OCI. Well, Docker is OCI compliant, all right? Hey, let's make containers be able to run in more places than just Docker. And so when we talk about image format and some of the build files, well, in the image format, we'll see there is this OCI, that Open Container Initiative specification, that can actually allow containers to run in multiple environments other than just Docker. So what version of Docker? Majority of people out there in non-production environments, all right, or smaller companies use the community edition, all right, as you'd expect. It's free. All right, Docker Enterprise is really, it's the leader in its category, and really goes ahead and provides not only, of course, the support, but it actually has additional features. All right, there's about 1,000 enterprises out there that use Docker Enterprise, and so you'll see Docker EE and Docker CE. Okay? And Docker CE is the one I have much more experience with, because that's what most people tend to use. Because when we start using this, you're going to find is you don't need that much support. You know, a lot of people pay for Red Hat Linux to get that additional support and some additional features instead of using CentOS. It's kind of the similar thing here. But what are the things? How did they build Docker on top of Linux? What they did is they took some of the capabilities that Linux had and used those. So we kind of went through a little bit of evolution as we started using these features. We have something called namespace. Namespace is going to allow me to isolate, separate out, all right, processes here to go ahead and say, hey, listen, I can limit what processes this guy has, what processes this guy has, and it makes them run in separate spaces, all right? We'll see some of these different spaces or different namespaces. So great, we're able to isolate. But a challenge would be, what if one of those guys starts hogging all the resources? Well, that's with C groups. All right, with C groups, we can go through and put in resource accounting limiting. Hey, listen, you can only use up, this much memory or this much CPU. And so those two things are really key. We want to be able to isolate these containers from each other. But we also want to be able to control the amount of resources a particular container consumes. Let's first look at namespaces. Namespaces, we have lots of different types of namespaces that are out here. We see some of them on the screen there, all right, and they're pretty intuitive. Mount is obviously at the file system level, all right. When we take a look at UTS, this is Unix time sharing, and so this is how go ahead and isolate hostname domain, but mainly on the also on the time sharing. The IPC is one of the big ones, inter-process communications. So this is one of the places where we're able to truly go ahead and start to separate out these. Some of the other ones, process ID, network. We'll be talking a good bit about networking because networking is interesting in this environment. Imagine, if you ever try to run on a regular machine, whether it's your desktop or a virtual machine, you try to run two processes that both want to run on port 80, you have an issue. Well, we're going to have a bunch of containers that might all want to run on port 80. How do we handle this? We need to make sure we understand how we do this and how this network isolation works and how we're able to isolate one network from another network. We then go ahead and for user ID, groups ID separation, and then that's C groups. That C group is really important for us, all right, if we go ahead and be able to isolate and control resources. So basically, we go ahead, we have these different namespaces. In this case, you can see Nginx in the center here, the web server, and its appropriate namespaces. This is isolation. Basically, when you think of namespace, just say, hey, this is my own little space. I only see stuff in my little space, right? I don't see other people's stuff. I don't affect other people's stuff. I only have my stuff, and that's it. Now, the next thing is like, well, okay, I want to use memory and I want to use CPU, all right? And so Docker uses another Linux technology called control groups, or C groups, right? So C groups limits an application to a specific set and amount of resources. This is going to allow us to be able to share resources. We don't want one container, especially if somebody makes a bad container and it goes nuts and has a memory leak and sucks up a terabyte of RAM or something. We can't have that happen. And so we can limit, hey, how much memory, how much CPU. These are a very important component. And the idea here is to ensure that we get fair share of memory, CPU, disk I/O, and more importantly, to make sure one container doesn't take down the whole system. All right, we don't want to be able to affect. And this sometimes will be used, denial of service attack, especially if we have one container being DOS attacked. We don't want to affect other containers. We want to be able to limit it. All right. And C groups were around for a while, eventually got merged into the kernel in 2.624, but they are cool, right? These two things together are the magic of containers. We isolate and we control. We isolate with namespaces, we control with C groups, all right? And so this is what we're going to be able to do, is we're going to be able to create these individual isolated systems. And we'll start looking, we have different ways to be able to deploy them. And when we look at them, it can be a little bit. We mentioned pods before, and we'll get back into talking about pods. But the question becomes do I want to deploy services as a single pod or as multiple pods, right? And I have options to be able to do this. And so, there's kind of a couple different ways to accomplish this. You can see that Linux containers, Solaris zones, BSGDLs all go with that one, where Docker, and then Docker's improved Docker Rocket, goes ahead and separates out everything. And this is more what we tend to do. We go ahead and we separate everything out into individual pods. We run one container typically per pod, and they have their separate resources, but they have a shared kernel. Now, how is this all going to work together? Well, we're going to install Docker, right? We install Docker, and we install it, right? It's a daemon. We install the Docker daemon, and it's a service, right? Just like if you run a Windows service, it's running in the background. That service is running there all the time. The Docker daemon has a REST API, right? So Representational State Transfer Application Programs Interface. It has an API for communication, right, that it can talk to. And so anybody could write their own tool to talk to the Docker daemon. And there are a lot of tools out there that do. All right, we mentioned Kubernetes as well as a lot of others. But the most common tool that people use is the command line CLI, the Docker CLI. It's the client. It's a little command line tool that we can tell the server what we want to do. We type in a command, it gets translated into an API call, and from the API, it hits the daemon. And so this is what's happening. It's basically, we're going to be doing demos. We'll be talking a lot about the Docker CLI, but there's other ones that out there that interact with Docker, and some companies write their own. They have their own tools that actually talk directly to the Docker daemon without using the CLI. All right. It's easy to make your own. There's lots of libraries for different languages. The one I've worked with is Python. There's a nice Python Docker library. Makes it very easy. And go ahead and automate things. And so it's kind of a nice idea. We're going to be using the CLI and talking a lot about that because that's the fundamental tool that most people use. Now we started thinking about the CLI. We can use the same CLI to interact with Docker. All right, the same CLI, the same client, I don't care where you're running Docker, we can use that same client to talk to them. So even though we might have some of them running on Ubuntu, some of them over here running on Fedora. Fedora, of course, is Red Hat's kind of beta edition, right? And CentOS is their community edition. We can talk to them. The API is the same no matter what the underlying OS is. So we're going to take a look at this Docker CLI, and we have some basic syntax. We're going to use the command Docker, right? We're going to say Docker, and then we're going to say, hey, what do we want to do? Okay. What do we want to do? And then we tell it what we want to do. We say, we want you to do this to this. In this case, they want it to run a container that has the name Hello World. They want to go ahead and create a container based on Hello World. We have different commands. You see a few of them over there. We'll be going over these more. We can see a couple of them there. Pull is to get it from a repository. When we talk about repositories, it's a place where people share and store images, either publicly or privately for a corporation. We have an images command, can list all our images. We have run. This creates a container from an image, all right, and runs it and executes it. And so we have all these different kind of commands that are being executed. So when we start thinking about this, let's think about what we have going on, all right. First thing, we start looking at this, we're like, okay, hey, I installed Docker on a host. Great, I installed Docker on a host. Well, right now it's running, but I don't have any containers yet. Well, there's registries out there, one of the most popular being Docker Hub. Docker Hub has thousands of pre-built images that you can look and that you can play with, all right? And so you can go to Docker Hub, see what you want, and then you can do a command like Docker pull, all right, to go ahead and take and copy one of those images. We're going to see these Docker files down to this environment. And then we can do a Docker run command. Now the first time that we go ahead and we do a Docker run, it has to do some building for us, all right? So the very first time you run an image, it takes a little longer. After that, it'll be almost instantaneous. But when we do go ahead and we start doing this, we build the image and then we create containers based on that image. And every time if I did Docker run Hello World 10 times, it would create 10 different containers with different tags, all right, based on that Hello World image. So these are really cool tools. We're going to be using this a lot. We'll be playing with this. We'll see how it works, understand the different components. And it allows us to see, hey, what are all the different ways that we can grab these? So let's think about our big three components. All right, we're going to look at our few components. And really for us, some of the biggest things are going to be the client, the daemon, and of course these images that we get on our server. So the Docker daemon, runs, if you look at it, as Docker D. All right, it listens for API requests and manages the Docker objects. It manages the object containers, networks, images, volumes, all that kind of stuff. All right. The Docker client is a primary way most Docker users interact, and then we have these images. Okay, an image is a read-only template with all the instructions that we need to go ahead. We want to go and be able to create things. To build our own image, we're going to create something called a Docker file. And from that Docker file is simply a list of all these instructions, all this syntax needed, all the steps needed to create the image. And we're going to see how that creates this image. We'll see it's a layered image, and we'll look at some other components. But we're going to go through, it's going to create this, and these images are going to be key for us. All right, these Docker images are what we actually create the containers from. So think of the Docker recipe is kind of like, okay, hey, this is what you need to actually build the image. And then once we build that image, we are then going to go ahead and use that as a template to create individual Docker containers. So to create the containers, right, we go ahead, we do a Docker run command. Is one of the most common ways that we'll create. A container is just a runnable instance of an image. We can create, we can start, we can move, delete the containers using either the CLI or somehow the Docker API. We can connect to networks and storage. And a container by default is pretty isolated from other containers and the host, but we can control how isolated it is. And a container is defined by that template as well as configuration options. It's like, okay, hey, this is what we want to do. But for this particular deployment, we can specify options. And basically, very important, when we remove a container, the container's gone, right? When we go ahead and we remove a container, it's gone. It is not persistent, all right? You want your stuff stored. Things that you want to survive need to be stored. You know, containers are ephemeral. They come, they go. And so you need to think a little bit about storage. Docker Hub is a cloud-based repository. And the most popular one, Docker users go ahead, create, store, do all kinds of cool things in Docker Hub. We can access this. There's all kinds of images here. In addition, you can create your own repositories, right, or use Docker Hub or other services. Most corporations will have their own Docker repository. Let's take a look at Docker Hub. So this is our basic Docker Hub environment. And when I'm interested in something, I can simply search there. And what you'll find is there is a tremendous number of containers that are available. Whatever you're interested in, if you're interested in things related to Microsoft, we show up with a 1,443. If I'm interested in just SQL, I can see I have 3,000. There's just a tremendous number of containers that are out there. I search on games, you can see there's a lot of different ones related to games. So it's very kind of a cool environment. Some of these will be Docker certified. Usually what we look for if you're going to download something here, a lot of people use MySQL as an example. I love to see if I can see an official image, right? And usually I'm looking at the number of installs. When I see, hey, 10 million plus installs, it's probably a pretty safe bet this is okay. If you go ahead and you see something kind of strange with 3 or 4 installs, probably something that you want to avoid. If I click on one of these, I can see MySQL, and it goes through and says, hey, here's the image. Here's how I get the image. It even gives me the command, and I can even copy it. That's the command that will actually pull that to my server, my Docker server. And it tells you some basic information, and they'll all have some details. Some of them will have more details, some of them will have less details, some of them are not overly descriptive. And so it's kind of nice to look at these and see what's going on and see how many are out there. A lot of times when you go to build a container, you might say, hey, listen, I want to go ahead and see, did somebody already build something close to what I want? And so you can take a look at, there's so many different containers that go ahead and accomplish different things. And they're kind of fun to play with and see what's out there. So once we got the container, we're ready to start using our Docker engine. Now our Docker engine is composed of a number of components. This is the underlying, Docker D that's making this actually go and making this actually function. It supports tasks and workflows to build, ship, and run container-based application. And so that process that's hosting these images, containers, and networks is accessible via the CLI. We see some of the different components inside of this. We notice we have some of the tools that we use. There's tons of plugins available for this. And notice that these are some things that are making things work, that are happening in the background. Let's think about one of the big ones is that container D. All right, so the container D got separated out separately around about version 1.11 or something, but we have a few components. And so we have we do our command here, it gets sent to the Docker daemon. Docker daemon has a subservice called container D, and we see this run C. Run C, it's built on libcontainer, all right? This is what's actually powering the actual container, all right? Everything's really kind of key. The run C is really going to go ahead, that is doing them working and really doing the job, all right, inside of that Docker daemon, inside that Docker server. It's that run C component. You'll find that there's some other systems that have come out recently that actually directly talk to the run C process, but we'll talk about that a little later. We're going to focus on Docker right now. So we have all these things that we need to talk to in this world. We have all these different components out here, from the network, images, containers, data, all these things. We're going to see how they work together. Docker brings it all together very, very nice. It gives us a lot of features. It lets us deploy our code with significantly less time and effort. It can be used in all kinds of environments. And the cool thing is these containers are portable from environment to environment. It gives us higher productivity, but because the deployment, we know that, hey, if it works as a container on the developer's desktop, it's going to work in the data center, it's going to work in the cloud. It isolates the applications. It does all kinds of cool features there. We have different ones here from something called like a routing mesh. We're going ahead and we'll be able to publish and say, hey, I'm advertising services on a particular port. We'll look at services in particular and say, hey, how do I go ahead and figure out where a container is located? How do I get to the container that I actually need? Docker Swarm is kind of lost, so not so much Docker Swarm anymore. It's for clustering, scheduling, and manage a bunch of Docker environments. Kubernetes has pretty much kind of bit one in that particular one. The security management, obviously, here allows us. We're going to see we have different ways to save information, like we use Docker secrets and other commands to be able to store important information. So, we think about some of the things here. Docker containers, all right? Containers are a tiny bit slower, all right? They're going to be. Why? Because it's another layer, right? We go ahead, they're not going to run at that bare metal speed. And so it's going to run a tiny bit slower. Container ecosystem, the different companies, there's a lot of different ones, a lot built on core, but it's not very, as you go from one company to another company, you'll see that the way they use containers can vary a lot. Okay? Storing persistent data, a little bit challenging because the data needs to be stored somewhere else, whether it's in a database and different Docker volumes or how you want to be able to handle this. A lot of environments, I love storing stuff in databases, but that's not always possible depending on what you're doing. Another issue, graphic applications. Graphic applications, this really isn't designed to run graphical interfaces, right? If you're going to do a graphical interface, you're probably going to be running a web server that's going to provide a web interface into your application. Okay? Technically, there are some creative kind of ways to do it, but generally, that's not where we're going to do this. And keep in mind, not every application is going to benefit. The ones that benefit are the ones that you can break down into microservices. Given that, you're going to end up with a lot of containers and a lot of Docker deployments. And so when you end up with a big cluster of containers to manage, we're going to use different tools. Kubernetes is the king, all right, abbreviated K8S. This is the one that most people use, and many of the clouds out there use Kubernetes. So you're like, oh, I'm going to use, GCP. I'm using Google's cloud. Underneath, it's Kubernetes. And hey, I want to use Kubernetes in Amazon. We can use Kubernetes in Amazon. I want to use Kubernetes with OpenShift. Well, that's what it uses. So it really is the dominant one. There are other ones out there, Docker Swarm, Apache Message. There's other scheduling tools that really make it a lot easier. And we'll see that those tools make it more like managing vCenter, right? We can manage a lot of individual VMware hosts. We're going to be able to use Kubernetes to manage a lot of individual Docker hosts. So that winds down this section. Thank you very much. Welcome to the section on install Docker, how we install Docker on Linux. Now, before we get into how to install it and the different things, I want to show you one of the easiest ways to be able to do this. So there is this whole process, and we'll go through all the requirements and all the individual steps, but fortunately for us, they've created a very easy way to do this. If you go to the website, get.docker.com, when it comes up, you'll see it's like this script file. This is a script they built to make it easy. And you can see the steps to go ahead and execute, they're just 2 steps. I'm going to show them in Notepad. The first step to install Docker is you get this script. It's going to do all the work for you. It's going to do all the steps that you would normally have to do. The second is you run it. Okay. After you run it, you can start Docker, and then we can go ahead and create a container and run a container. So let's go ahead and let's see if we can see this in action so that you realize, hey, anybody can do this. It's easy to install on Windows, Linux, or anything. Windows and Mac, they have separate installers that we can use. So we're simply going to copy these commands. Right? I go ahead, I'm going to copy these commands. I'm going to right click, paste the commands. The first one was curl. That reached out to the website, download that text file, and it output it as get-docker.sh. This is now going to run the shell for get.docker. It's going to run that script. So I go ahead and I press enter. Now there's a number of steps that we need to do to get Docker installed. Fortunately for us, this script goes through all the steps. We see it's making some changes. It's adding a repo, right? So we see, okay, great. It's going to go ahead. We added a repo, and that's a repository. That's where the actual Docker files are stored. Then they grab something from that repo. And they go ahead and start to execute. And you see it's going through an installation. It's kind of chugging along, all right? And we see it kind of processing the actual file. As it downloads the different components, we see them being downloaded. I'm going to scroll this up just a little bit. Okay. And so as this installation continues, it simply chugs along and makes it very easy for us to be able to do the installation. It can be to install Linux. Next, we'll start taking a look at some of the functions, some of the commands, and some of the options we have. Now, when you start thinking about the hardware, it has been running, where can we run Docker? Well, we can run Docker just about anywhere, not only in Linux and Windows and cloud, all kind of smaller devices, even IoT devices. And some of those are really designed to run in very, very small environments. Now, the requirements, very easy. Well, where can I install it? Supported. Well, you can get to run just about everything. But supported-wise, we have Docker CE, the Community Edition, and EE, the Enterprise Edition. We can see the support here. The support's continuing to grow, so it's always kind of nice to go back and check and say, hey, what has been added? In addition to what's on the CE, the Enterprise Edition gives you some additional features, right? And so it gives you the ability, it's a supported environment, different encryption, different signage. They go ahead and has a lot of very cool things. It lets you get easy access to certified images, certified plugins, be able to go ahead and have kind of a single pane view, access cluster management. That's a lot of kind of cool things, all right? But most people do the Community Edition. But the Enterprise Edition, we have something cool too. We can go ahead, and if we have a bunch of separate physical or virtual machines, all right, we can create a container cluster using the Universal Control Plane. Of course, most people tend more now to go with Kubernetes for this type of things. Release-wise, what happens? Well, you have the Edge releases. The new releases, not quite beta, but they're relatively new releases every month. Quarterly, we have the stable, and the stables get patched. All right, Edge releases don't get patches, you just get a new version. And then for Enterprise Edition, twice a year, they go ahead and they have that solid, reliable, supported edition released. So what do we have to do? Well, we have to get our host up and running, networking, get it functional, install some packages. Now, we saw a script that did it for us, which made it super easy. So let's take a look at some of the things. First of all, if you're doing it on CentOS, you can do a yum install, all right, Docker CE, the CE CLI container DIO. Okay. Now, chances are you're going to be missing support files, so when you go to run it, you'll be missing. You have to go, and you can find some easy online guides. I personally find the easiest to go ahead and just go to get.docker.com, grab that script, and run with it. Once we have Docker installed, we can then actually go through and we can run a variety of commands. I'm going to bring my interface up here. And let's take a look at some of the commands. Docker info, Docker version, very simple, right? Docker info gives me a ton of information. I can see what's going on, version I'm running, then storage is overlay 2, logging, runtime, all that kind of information is very cool. And I can see the amount of memory. This is a relatively small machine. Docker version, of course, will tell you what version that you're running of a particular. And we see here we're running the client is 1903, all right? And so we can see, hey, exactly what's running. And if the first container most people run is the Hello World container. So I want to keep you in mind, when I press enter, it's going to spin up and run the container, and then it's going to finish, because this is just a quick little container. But notice how fast it spins up the container, execute the container, and then finishes. 1, 2, 3, go. It's done, right? So pretty crazy. It's pretty awesome. Some of the other things we probably want to do is set it up to boot automatically. Okay. Now, keep in mind this Docker daemon. It binds as a Unix socket, not as to a TCP port. And so the Unix socket is owned by root, so the Docker daemon has to have that root access. And we have a couple options. We can log in as root, or we can go through and create a group and add users to that group. Okay. One way is to make sure it's running. If we go ahead and we do a PS, and to look at the processes, I can see, wow, there's a whole lot of processes. How can I narrow it down a little bit? All right. I can start taking a look and say, okay, hey, what am I getting out of this? What am I listing? That confused me there. All right. And you can see a lot of the Docker containers. Now I normally do a PS-A, which will show me just about everything. And then let's go ahead and grep. And then we can see that the Docker daemon is running. The other one we're usually looking for is the container D. And there's the container D running. So easy to get up and running, very quick. Doesn't take much time at all to get this functional and working. And once you have it, you're able to start, run, and manage containers. And that's the end of this section. In this section, we're going to talk about managing Docker containers, and we'll be using the Docker CLI to accomplish this. When we think about the container lifecycle, there's kind of a whole process if you think about it, right? First, we kind of got to acquire it, maybe from Docker Hub or somewhere else. We're going to get that basic Docker file. Next thing, once we have the Docker file is a list of instructions on how to build the container. So then we go ahead, we build the container. And now we're ready to go ahead and be able to run it. We obviously need to figure out where we're going to deploy this, then we get through the deployment process, and then maintenance, and of course, finally, eventually killing it. We're going to be doing some demos here using the Docker CLI. Now, if you type just the Docker command, it'll show you all the possibilities. We see one on there that we'll be using a lot, which is the Docker PS, as well as the PS-A. Some of the basic commands that we often use. The idea of building the image, that's great. You can go ahead, you have a Docker file, and if you're creating your own Docker file, you're going to take that Docker file, then you'll build your image. Oftentimes what we do is we're grabbing it from an existing repository like Docker Hub, so we can do a run. That'll actually go out, grab the Docker file, build it, and then start a container, which is pretty cool. We have the ability to go ahead and persist in a container, but based on a new image, which we know that's in the commit. And then we have run. Go ahead, and that's the one we usually use to go ahead and start a new image. Additionally, we can go ahead, we can kill a container or stop a container. Kill a container is kind of the brute force. Boom, it's like pulling the plug on the container. All right, it sends a signal kill. If, however, you go ahead and do a stop, it's kind of a more polite. Most of the time, we're not polite with our containers, so we just kill them. Start a container has been stopped. RM to remove the container. And then RMI, that actually deletes the underlying image, which means you would have to build it again. So let's explore some of these. And the first thing we typically want to do is get an image. So here I am on Docker Hub. And let's say I want a web server. So I do Nginx. All right. And if I take a look and I click here, it tells me the command, docker pull Nginx. That pull command would bring the Docker file down to my machine, and then I could use the build command to be able to build. What we're going to do is we're going to use a few different simple commands to get this up and running. Docker run command will pull, build, and run a container. So let's try that first command. Okay. And we're going to see exactly what happens when we run that command. There we go. And what we can do with this is pretty slick. The first thing I do the Docker run, and what happens here is I'm running this from my terminal session. And it's going to actually take over my terminal session, and now I can't do anything. So if you just do a Docker run, that's kind of the interactive, you're there at the container. Right? For a container that you want to run for a while, what do we want to do? Well, we want to do more that we want to have it run in the background. Now, if it's a container that's going to run and then end, that's fine. But if it's a container that we want to run in the background, we use the -D option. So you notice when you run Docker by itself, it gives you lots and lots of your different options and settings. All right, we can do a help and get even more information. We're going to be using, of course, the Docker run. So if we do Docker run --help, we'll see the different options. And one of the options here is the detach option. All right, run a container in the background. And so let's go ahead and give that a try. So now it's running the background. If I do a Docker PS and I look at this thing, I was like, okay, hey, it's running on port 80. wait a second, I don't want to be running on port 80. All right, that's not a good thing for me. And so I want to go ahead and I'm going to stop the container. I'm going to kill the container. Because if I'm going to run 10 of these, I can't have them all running on port 80. That'll create problems. So we can do the docker kill command. And then we can specify. And we'll kill all the containers here. Now when you kill a container, and I do docker ps, I don't see the container. That shows me the running container, but it's still there if I do the -a, right? So I can see I have a bunch of containers. The docker ps-a command is going to show me everything here, and I can see I have a lot of containers. Now I can remove these containers individually with the rm command. We'll get rid of that first one up here. And now when I do that same command, I'm going to see that first guy that ended in 59. All right, he's now gone. But what if I want to remove them all? Wouldn't it be nice if there was a simple command that would go ahead and kill everything for us? Well, let's take a look at this command, docker prune. Now I go ahead and I try to run docker prune, and it gives me this kind of message like, hey, what the heck is going on here? Well, some of the commands we can type directly, some of them have to have the word container. So sometimes we need the container command, sometimes we don't. In this case, we do. So I'm going to go ahead, I'm going to say yes, and it went through and it just cleaned up all of my containers. Okay. So we have a few different ways to run containers. Now I'm going to run some containers, and what I want to do is when I run them, I'm going to run them with a -d, so they run in the background, and a -p where they select an available port above 3268. So when I run this, I'm going to run this command. Now normally Nginx wants to run on port 80, but I'm going to run a lot of these. I can't have them all running on port 80, so I use the -P. Later on we'll see how to map to a particular port. I'm going to run a few instances of this. All right, and now when I do my docker ps, I can see I have 4 instances, and I can see the ports 3278, 77, 76, and 75. Right. So what if I decide, okay, let me open up a web server, a web browser, and let's see if this fun stuff is working. Okay. So we saw, with this case, when we took a look, let me double check those ports, we had 32775, so we're going to go to 32775, and we're able to connect. Now let's go ahead and kind of verify that, because I see 32778. Let's try 32779. We don't have anything running there yet. And you notice what happens. It's just up there, it's trying, it's hanging. But if I go ahead and I spin up a web server, now watch how long it takes to spin up the web server. Ready, set, go, done. All right. Now there's a web server there. All right, let me make sure we got the port right, 32779. Yep. So I'm going to go ahead and now we're able to connect, and it's there. So it's so easy. I just spun up, a bunch of web servers. It is that easy to use containers. All right. There's some different kind of commands. There's not a magic command to stop all the containers that's built in. So what often we'll do is we'll use this command. This is kind of cheating, right? We're going to go ahead, we're telling it to stop, and then we're doing the docker container list command. And this way we're saying, hey, we're going to list all the running containers. We're going to stop them. So it's kind of a cheat command. You can Google it. It's all over the place out there. And this will stop all the containers. So now when I do PS, I don't see any, but PSA, they're still there. And of course, then I can do my docker container prune. If I don't hit the caps lock key. And now I've cleaned up after myself. So we'll be playing around the Docker command line in just a moment here. I want to talk about a few of the commands that we haven't talked about. Pause and unpause. What does that do? That pauses all processes and goes ahead and then resumes all those processes. So those are pretty handy. We can demonize a container. We'll talk a little bit about that later. We can rename a container. And of course, we can search. We can go and find. We'll see some examples of this in a little bit. RM and RMI. All right, one removes the container. The other removes the image.
Save and load. All right, so we have a couple commands here. Save goes ahead and saves an image to a tar archive, right? So it goes ahead and saves it, and then loads that image from that tar archive. So if you had an image you wanted to give somebody, you could go ahead and tar it and send it over to them. Okay. We have a couple other commands that we can go ahead and that we can use. We can use attach. That'll attach to the local input. All right, so you can go ahead and you can attach to it, and it's like you're on that. So if you wanted to run a container like a Ubuntu container, and you wanted to get to the Ubuntu command prompt, you could use the attach command. Stats is kind of nice. Stats shows you what's going on with all your containers, and a lot of times when we start, looking at a machine, one of the early commands that we'll often do is the stats command. And I don't have much going on, but it gives you a really nice, quick view into what's happening. All right, we have some other commands that are out there. We have ones like events, okay. And basically right now there's nothing going on, but this is kind of like you're going to see the console of the server, so you'll see events as they occur. Okay. And so these are some pretty cool commands. Copy files to and from. We can copy them from our local file system, all right, into a container, or vice versa. So let's move files in and out of a container. We have exec to go ahead and execute commands. We have difference to go through and say, hey, what's different and what's changed in the file system? We can look at the history of an image to see how many times it's been modified. And we did talk about kill, which kills a container. We can kill, then remove the container. And of course, prune removes all the containers. So creating a new container, okay, we can see here Docker create, and this is where you can give it a name. You may have noticed at this point that when we create a container, right, we've been using a command like this to create a container. And when we create that container, it gives it a name. So we can see it's kind of giving it silly names. What if I wanted to go ahead and give it a name, all right? Well, we have an option in this command, all right? When I'm doing this, I can say, hey, I want to go ahead and I want to give it a name. Maybe I want to give the name, and in this case, I use double dash, right? Give it the name, and then we'll want to call it, Now when I look at this and I do my PS, I can see I now have one called Fred. Right. And so some people do like to name their containers to go ahead and just make it a little easy when you're searching and sorting your different containers. All right. And like I said, otherwise that, it would go ahead and just give this a random name. I kind of like the random names sometimes. They're kind of amusing at times. So we run a container here. When it's up, it's with the Docker run command. It's sitting there running. We can go ahead, we can specify different images that we want to use, what version. If you don't specify the version that you want, you will get the latest version. Okay. And let's take a look here. They're doing a basic Nginx run, starting the container, and we can see it gets up and it's running. Okay. We can start with different options here. We can go through, we can specify. We're going to talk about, when we get to Docker files, how we can go ahead and have properties and override properties. All right, and we'll talk about exactly how that works. We saw the syntax, we start, stopped, all right. We didn't actually restart one, but go ahead and it'll restart one that's been stopped. Okay. Pause goes ahead and sets the stop signal, and we can unpause. We can rename. We don't like the name, we can go ahead and give it a new name, or we can use the name command at the beginning. If we want to list the Docker images, all right, these are the actual images. So when I look at my containers, I say, oh, wow, I have 4 different containers running right now. Okay. But how many images do I have? Let's take a look at my images. And I see I have a few different. I have the hello world, because I've run that. I have HTTPD, which is Apache. I have that. And I have my Nginx image. If I wanted to get rid of an image, remember we use the RMI command. All right. All right. And so basically it goes ahead. Now I take a look at my images, and I see that image is gone. All right. I did the repository name instead of the actual image ID. We can pull images. Now search is kind of nice, all right, so that you can say, hey, I'm looking for something. Instead of having to go to the web interface, all right, and saying, hey, I want to go through, I can actually just do a search command. And here's a whole bunch of Minecraft applications, right? These are containers that are out there on Docker Hub. And so it makes it really kind of nice to be able to search and play. And sometimes it's very quick, right? You know, so if you were looking for it, you know, like we did in Genix, we searched on the web. We do it here. It'll show us all the ones, and we can see whether it's official and some other information about it. So really kind of nice, all right, for us. RM and RMI are for moving the images, all right. If I want to be able to attach, all right, to be able to attach. So let's go ahead. Let's try a couple different commands. Now, I'm going to go ahead and run Docker, and in this case, I'm going to create a container. It's going to be in the background, all right? And let's go ahead and do CentOS, all right? And let's see what happens when I do this. So I go ahead and I press enter. What does it have to do? It has to download the components. And we can see here, it's going through, and now the container is running. So great. I can see the container is running. And I see, okay, great. It says go ahead and why isn't my container there? Oh, let's go ahead and give it a command. I'm sorry, we'll give it a, forgot to give it something to do. And so we see it went ahead, and now I look at my commands, and there I can see, okay, great. What if I wanted to actually get into that container? So I know that, okay, great, it's sitting there, it's running, it's CentOS. How do I actually get into it? Well, this is where we can use the Docker attach. Now I can attach by either using this one over here, or by using the container ID. So now I'm going to go ahead and you can see I'm attached. I ran that top command, so notice that's what's running, is that top command. And so boom, it's going to go ahead and we see that top command is running. Okay. So it's kind of interesting to play and use some of these different environments to see kind of how they work. Sometimes it's friendlier to give it a name. And be able to take a look. So if I wanted to give it a name, this is where I go through it. I just specify name. And then specify what I want it to do. All right. And so we know what application I want to run or whatever. And it makes it easier to reference it by name. And so pretty neat. We're able to play with these. We're able to use these. If we want to go ahead and instead of having to have an interactive shell, all right, which lets it go through and be able to interact. If we go through and we run it demonized, that means it's running in the background and you can't attach to it. All right. So just kind of keep that in mind. Let's take a look at attaching. In this case, we can go through, we can run it. Now in this case, running it with a few different options there. And so remember, when you look up a command, you're going to find a lot of cheat sheets online, and they're going to have you typing commands and not always explaining what the commands are. So it's always good to take a look at help and say, hey, what commands are they running here? Well, we talked about the D, which is the detached. Okay, fair enough. But now we're passing the I. Oh, interactive. That's cool. So this is, we're going to go ahead, we're going to do interactive, and then finally with a T, I'm going to go ahead and have kind of a TTY interface. So let's see how we actually make a container where we can easily connect to it. What did I do wrong? Oh, I was supposed to DIT, not DIR. I was like, what the heck? What is wrong? There we go. Let's try that again. So it's going to run detached, interactive with a terminal, with TTY. And so now when I attach to it, notice what prompt I'm at. I am not at my previous prompt. I'm now inside the container itself. So I'm actually in the container, you know, and if I do a PS-A, notice lean, right? Containers are lean and mean. This is from inside the container environment. If I do a PS-A here, now I'm back on my main server. Of course, I'm going to go ahead and I can see, hey, this is where Docker and all this stuff is running. So it's kind of cool. Monitoring stats shows up. The Docker info command we saw is a lot of information. All right, we can do a Docker events command where we'll go through, we can specify, hey, what type of events we want to see. All right, or do we want to attach and be interactive? The inspect command gives us information about a particular container. The CP command is how we copy. All right, copy files in and out of a container. Exec, all right, the exec command executes a command. I say, hey, when I want to run, I want you to execute this command. Or we can go do a diff, and this will show us, hey, what's changed? And so that we can go through and say, hey, what's changed in the system, in the image? The kill command terminates the kill or the stop command. Okay. So there are a lot of different commands out there. You'll get used to using them more and more. Eventually, when you start using a tool like Kubernetes or Docker or Swarm, you use these a lot less because you're doing everything with Kubernetes commands. So like for me, I don't use the Docker commands a lot anymore because almost all my deployments are Kubernetes. But it's good to know the underlying Docker command. And that is the end of this section. Docker images are interesting to think about and manage. We're going to find that in general, you don't spend too much time managing images, but we do want to make sure we understand exactly what an image is. It's a template, right? We're going to create a container based on this template. And we don't modify this template, it stays the same. We create containers, and containers go ahead and are built on top of this template. And I might have, 500 web servers running off a single image. This really makes it powerful. We're going to see how this works through an overlay system, and we'll see how they actually go. Now, we already talked about how to create a container, but we know this is going to be based off a template. Now, the way a template is built is in layers. So let's think about if I gave you a box, a bare metal machine or a virtual machine, I said, hey, build an application, what are you going to do? Well, you got to install your base image, maybe install Debian. Then you're going to start adding package and installing additional software. Well, the way that it works is when you go ahead and you say, hey, I want Debian, it goes ahead and builds that file system based on that. Then it kind of takes a snapshot and freezes it. We call that a layer. Then I say, hey, install Emacs. It goes ahead and basically in a new layer, any changes that were required to install Emacs are recorded in that new layer. All right, and that's frozen. Then I say add Apache, install Apache. On top, a new layer is created, and all the changes that occur for installing Apache are stored in that new layer. That's snapshot and frozen. And so when we think about these images and we think about how they work, all right, these guys all down here, right, these are all read-only. We can't change those, all right? There's no way for us to modify them or anything. When we spin up a container, it's given its own space where it can write all the changes that it wants, all right? And so the idea is that basically when it goes through, each of these layers hold the changes. The container layer, the writable container layer, having the latest and greatest information. And so you can just think about, if the Emacs layer added a file or Apache added a file or modified a file, we're getting the net result of taking these containers and using the most recent version we have of every single file. And so you can kind of think of these as our different layers, in particular our container layer. Great thing about this, this might be 300 megs for all this stuff, but great, I can create multiple containers with that using that same base image. I can use that same image with those layers. I can use them again and again and again. And it's very powerful and very efficient. Or if I created another system, but I still had base image based on Debian, I still get to reuse that same image. So when we create containers, containers are going to be based on a series of images. All right. And then when we create the container, it uses that underlying images. Let's think about how it works. All right, is we go ahead and we build our base image, and these are the files in the base image. We spin up a container. Each and every single container has its own separate layer. And, you know, if they modify, let's see, what are they going to see for file 1? Well, it didn't get modified as we go up to the layer, so it's still the original file 1 from the base image. File 2 got modified to the container layer, so they're going to see the new modified version. File 3 didn't get changed. File 4 did get changed, or actually added in this case, right? And so they're going to see that net result. And so this is where they're going to go ahead, and you can think of that merged layer. Now, Docker stores every layer. And there's some benefits to that. You know, a lot of reusability. Like I said, if the base image is Ubuntu and I'm using it for a lot of different kind of containers, the downside is it does take a tiny bit more storage. Later on in the course, we'll talk about some newer systems that actually go ahead and will flatten. And there are tools out there that you can run against a container to flatten it, meaning to merge all the layers manually. All right. But in general, we just let it be. It doesn't take up a lot of space. So for example, if I start 3 containers, let's see what happens. I start that first container. Hey, look, I consumed 230 megs of disk, right? Okay, fair enough. Now I go ahead and I spin up more containers. No matter how many containers I spin up, right, we're going to see that each of them are not going to take additional image space. All right, so each of them are going to go ahead. They have their own base image, but the read-write layer. And so it's kind of cool when we start looking at these is we don't take up more space. So when we think of the images, they're read-only. A container goes ahead and is booted and started up using that read-only copy, and then a thin read-write layer is put on top of it. How do we get Docker images? Well, we can create our own images. We can import. By far the most common way is we grab them from a registry. Biggest registry out there is Docker Hub, and we talked about Docker Hub as a place for us to be able to store images, be able to communicate with us, be able to push and pull to different types of registries out there. We can either do it via a public registry or a private registry. Now, as we start making changes to our code, we want to go ahead and we want to annotate what we did with our code, and we can use tagging. All right. One of the big things we use tagging for is to identify the version. So it go ahead, not only does it have it, so you can look at different versions and you can say, hey, this is this version, this is this version. You look at tags for some of the differences. And so we think about this registry, this kind of storehouse where we're storing all this information. All right. We can go ahead, we can have multiple repositories, separate versions. All right. And we're able to go ahead and create these and separate out. So here's one repository. We can see they have a couple versions over here. Here's another repository that has one version of that. And this is just a way for us to store. Versioning is very key because it lets us roll back and roll forward and verify, hey, what version are we using? This diagram shows, hey, we pull something from the registry, the Docker file, we build it, and then we deploy it in our containers. Where do we get this registry from? We can get it from just about anywhere, whether it's out in the cloud, right? Docker Hub being the big one, Amazon, or set up your own. It is super simple. It's only a couple commands to spin up your own registry, so there's not much to it. The commands for that's going to be a little different, but if you played with like Git and other things, some of them will look a little bit similar. A couple of the big ones are going to be pull and push, right? Pull and push are going to be very powerful for us because that's when we're talking to the registry. That's how we're going to push it to the registry or pull it from the registry. The other ones, we already talked about a couple of these with build, which oftentimes we'll just use a run, and that'll go ahead and do the build for us. We talked about RM, all right? That should actually be RMI, right? RM removes container, RMI removes the image, all right? We can do an image save, all right, an image import, an image load, and it's not on here. We can also do an image export. Right? So we can go ahead and we can do this. Difference, let's take a look at save. Save saves to tarball, all right, goes ahead and just streams everything out, and basically the export and import will look at a little bit, they're a little bit different, all right, than save and load. So Docker Hub, one of the most popular out there. It's easy, it's friendly. That's where you can find verified images. So you know, hey, that is the official image for that company. So you can drop out to Docker Hub, all kinds of cool things here, different repository. We can create automated builds that help you do your automated webhooks. Webhooks, say you tell it to build something, but when it's done, you want it to be able to call back to your server and say it's done. That's what we can do with a webhook. And we have role-based access control. We can create groups and permissions and privileges. So we can explore, it's easy to look at a particular image, see what's going on, we can drill down, we can find our images, and we've seen some of this before. Here's the Apache image, all right. I can look at which tags are available for that particular one, so maybe I want to go ahead and standardize on a certain version. And then I can look through my different repositories. It's easy. We can see descriptions. We can drill down and see exactly what's inside of these. And we can drill down even further and say, hey, this is what's going on, this is what's going on, and that's what's going on. And then we see a little bit more on the web host information. So, managing the repository, again, we can push, we can change, we can manipulate things. Repositories are easy, repositories are simple. And so there's something that we really like and something we really like to use. To set up your own is incredibly easy. All right, we can do it a couple different ways. One is through the Docker Trust Registry. That's a product that you have to purchase. The other is you can just go ahead and do a quick install locally. We'll want to take a look at how to go ahead and deploy this. Okay, most people when they see it sounds hard to set up a registry. We talk about the process here. We set up our storage, our customization, our backend, all that kind of stuff. But really, when it comes down to it, it's like, okay, well, that's all well and good, but how do I actually make it go? You can actually make it go with a single command, which is right here. Notice here, what are they running? They're running registry version 2, and they're spinning up on port 5000. Our inside and outside ports are defined here, and that is all there is. Registries are easy, they're friendly to use, you'll like them a lot, and it's just part of doing our Docker business. And that winds down this particular section. In this section, we'll be covering building container images. So there are two primary ways that we can build images. One of the ways is a Docker commit. And so what this is going to do, of course, is when you have your repository running and you want to go ahead and you want to commit your change to the image, this is one way to do it, right? So go ahead, we can commit it, and then we can push it to our repository. The much more common way is to use a Docker file. And that's the typical way we'll do this. Docker file will have a list of instructions. The files have all the commands that we need to do, right? And basically what we're doing is we're using this Docker file to say, hey, what if I was wanting to make and install a particular application? What would be my steps? Hey, I have to install these packages and these packages, then I install this. And so this really is what we prefer, our Docker files. So real quick, when we think about the Docker commit command, okay, it can be if you're trying to create a new image. That's one of the few times we do tend to use this. Allows us to go through and be able to run things and do a couple kind of cool things. In general, it is much better to use Docker files to manage our images because it's documented, it's maintainable, and that's really important. The commit operation will not include any data contained in volumes mounted inside the container. By default, the container being committed and its processes will be paused, okay, while the image is committed. This reduces the possibility of data corruption if you're trying to commit while data is being changed. So it pauses the processes and then it does the commit. So just kind of be aware, we can do these commits. What if I want to go ahead and I'm like, okay, hey, it's running on my machine, this image. I want to go ahead and share it with a buddy. Well, the way that I do that is to move it from host to host. I can do an export. And so when I want to go through and I say, okay, great, I want to take this, I want to export it. We have two different ways, export and saving. Docker export saves a container's running or paused instance. Okay, so think about that. That means that particular container, when we do the export, it's like a snapshot of that container while it's running. Docker saves is for a non-running container, and it saves the image. So it just kind of exports a snapshot of a running container. Save is a non-running container image. But if we go ahead and we do an export, what do we do on the other side? Well, we can go through and actually create and run the application. This is just a way to be able to move it. Remember, this is like a snapshot. You want somebody to see exactly how it's running right now. This is a snapshot, not just a copy of the image file. But really, Docker file is the preferred way. When we consider Docker file, this is going to build the image from a set of instructions. It's a small text file that says, hey, these are all the steps that we're going to take to deploy this particular application. And if you take a look at what we have on the screen here, let's break that down a little bit. Here, they're using Debian Stretch Slim. All right, it's a lean version of Debian Linux. Okay, they're going to run the command D package. So D package, add architecture. Now they're going to run an apt, right? They're going to do an update. They're going to do an apt install. And what are they going to install? Well, they did the -y so we don't get any questions, right? And no additional recommendations. And it's going to install all of these packages. That backslash at the end is just a line continuation, saying, hey, the line continues. All right. And here they're going through, they're moving some. Here's the working directory. All right. And it's kind of neat. We can kind of watch what it's doing. Now here we're going to go ahead. They're going to run. They're going to run a make file. And then finally they're running a find command. And then the final thing they do is a command hello. And so we'll be talking about what's inside of these files and what they mean. But they're relatively easy to look at. And we can start going through and verifying them. So for example here, I can grab the Docker file. So when I'm looking at Docker Hub, I can grab the Docker file. Here's the Docker file for MySQL. If I pull that up, and a lot of times you'll see some of these official images have a little bit more logic than ones that we tend to make. But basically we can see, okay, hey, we have some groups. We're going to go ahead and run an apt install. And now we can see they're doing a bunch of commands, right? Apt-get, wget, and doing this all as a bunch of commands. Notice they're stringing the commands together. That puts them all on a single layer. Okay? And we'll worry more about that later. But it just puts them all on a single layer. We can see some additional commands, and that's just what the file looks like. And so a lot of times, if you're going to build your own Docker file, you can use somebody else's as a base. Let's take a look at a few of the commands. So when we think about this, it's going to be from the Docker CLI, and we have a few different ones here. Two of the commands are a little confusing. You see add, copies a file from the host system onto the container, but we also have the copy command. Okay? And so we have some different ways, but hey, I want to copy a file. CMD runs a command. Entry point allows us to go ahead and configure a container that will run as an executable. We'll talk about entry point because entry point and command are very similar. We'll see there's some differences between them. Environmental variables, be able to go ahead and expose a port link from what's our base image. So that's going to be the very first line. It's going to be, from CentOS or from Debian, from whatever. All right. And maintainer, we don't really need that anymore. Some commands we do on build, run, user, volume, working directory, they're all relatively straightforward commands. Let's take a look at an example. When you go to build these, first of all, don't install unnecessary packages. Okay? You want to go ahead and make them as lean and efficient as possible. When we take a look at this command, they're going to base it on the CentOS. They're going to update, They're going to do wget, and they're grabbing this file, right? So they're grabbing this file, and now they're doing a tar, so they're unzipping that file, and they're adding myscript.py from my local machine, right? We're adding this into the root, and here's the command. They're going to go ahead, they're going to execute Python, they're going to execute my script, and then that's the command. To actually build it, we can do a Docker build, right? And specify, hey, this is what we want to build. And by default, it'll look for the Docker file in that local directory. So what's that first command about? From, right? This is where we can go through and we can create and say what we're based on. Almost all the time, it'll be from and then the operating system. And there's a bunch out there, and you'll find that different companies tend to standardize on different ones. There are a lot of stripped down ones to go ahead and keep things. So you'll find, there'll be like a full CentOS or a full Debian or a full Ubuntu, but then there'll be stripped down ones that allow you to be a little bit more efficient. I use Alpine a lot as it's a very lean way to go ahead and build images. If you're going to go ahead and you're actually going to create your own base image, you go ahead and you say from scratch. And that means from nothing, and you're actually going to build the base image, which most of us don't do. Almost all of us are going to use something else as a base image. But in general, we want to go ahead. We can do this. We can tar it. Right? So we can go through it and say, okay, hey, what do I want to be? Well, when we want to go ahead in distribution and we want to say, hey, there's some tools, we can use those to help build images. And so in this case, you can see they're going to go ahead. They're doing a debootstrap of Xenial into DevNull, and then they're going to go ahead, they're going to tar it up. and then I can do, okay, great, and then import it. It'd be one of us ways to go ahead and, kind of get creating our own full image. It's one of the ways to create a full image. When we're doing this, we'll usually do this after we get that tar going. We start with it from scratch, and then we add in that. So I was going to say, okay, great. Hey, this is what we're starting from. And usually this is the people that are building the base images, that are building that, Debian, Linux, Alpine, all those images, not a typical user. Typical users are going to be from, and then the OS that they want to use. The copy command, all right? This does just like you kind of expect. We can do a copy. A lot of times we'll also do it might do a change ownership to go ahead and when we're building the containers. But typically what we're doing here, we're simply copying files, all right, to go ahead to the file system of the container. And so this is pretty slick. We're able to do copies, all right, but there's a more powerful command. It sounds almost the same, all right, but it allows us to not only copy local files, but it does a couple things. One, it goes ahead, automatically unpacks tar files, and two, we can use a URL. And so I can specify a web to grab it. So in our example, we have Python FTP blah, blah, and it's going to grab that image. So add command has, for many people, is kind of superseded. You still see copy there a lot, but the add command gives you a little more flexibility. The run. Well, the run command, just like it says, it's going to go ahead, it's going to execute whatever you're going to do. The run command creates a new layer. Okay? We're going to have these layering here. And so sometimes what we'll want to do is, if we don't want to create a lot of layers necessarily, we can go ahead and use one run command, and using that double ampersand, run multiple commands with a single run. CMD, all right, there's only one of these. So you only get one of these here. This is the default command. Okay? This provides the default for executing it says, hey, when you do this, what's going to happen? All right. These can go ahead and we can say, okay, well, this is the default command. We can override it. Okay. Or we want to go ahead and say, what if we don't want them to be able to override it? We want it to always run no matter what. Okay. Well, if we don't want them to be able to override the CMD, we use an entry point. Entry points used in scenarios where we want the container to behave exclusively as if it were an executable. It runs and acts and executes a particular thing. And so sometimes we'll go through and we'll package. Maybe we have a utility or a Python script. And when we want to go ahead and package this, we simply want somebody to be able to run this container and it automatically run that Python script no matter what. Just kind of keeping it nice and simple. We have a couple other commands. And so we have the run command. We talked a little bit about the run command, entry point. When we start thinking about the shell command, okay, and we have a couple, kind of that shell versus that exec format. The bottom one is in JSON format, okay, and the top one is go ahead and actually creates a bash shell. So one of them actually directly runs the binary. So if we use those brackets down here, that is going to go ahead and it's going to poof. It's going to run that directly in a binary. It's not going to spawn a bash shell then run it. If we do it this way, it's like we're doing a shell command and then running it. So you both have a couple different ways to do this. In general, for the command and the entry point, we prefer the second one, right? We go ahead and we prefer where we're able to say this in that exec format versus the shell format. You will see a lot of people going ahead and using the shell format because it's easy, it's simple. Expose command. Now, when we do the expose command, this goes ahead and expose the port, makes it available for containers to be able to talk to each other. So we have two containers. We want them to be able to talk to each other. You know, one's running Node.js, one of them's running a Redis server. We want them to be able to communicate with each other. This allows them to be able to talk. And so we can say, hey, I want to expose port number XYZ, and then it makes it available to communicate. And that's for the communications between containers. But what if I want to allow it to talk to the outside world? Now, earlier we did some examples, and I said, hey, if I do a capital P, it'll pick a port. Because remember, we might be running 10 web servers, and internally they're all running on port 80. So how do we make it where on the outside they have a different port than they do on the inside? Well, we can use the lowercase p, and say internally it's port 80, and external, oh, I did backwards. We want it to be 8080 on the outside because it's 80 on the inside, and the next one we might run on 8081, but still it's port 80 internally. And so I might have a bunch of web servers running. Internally, they're all running on port 80. Externally, they're running on ports 8080, 881, and 882. Okay. If I don't do this, they'll all try to run on port 80 and things won't work. All right. The other option is a -P. When you do that, it's going to pick a port number starting at 32768. It's going to find an available port between 32768 and 65535, and will pick an available port number. Normally starts at the bottom and works its way up. But that's kind of important, when we're running multiple containers that want to expose the same port to the outside world. Labels are for metadata, right? Extra data, so we go back, we can look and then go say, okay, hey, this is what's going on. Labels are very powerful, okay? Try to put labels in there. They're a little bit of a pain, but you will really appreciate them later on when you're trying to figure out, hey, what the heck did I do? And things like that. Environmental variables, this allows us to go ahead and set environmental variables just like we do externally, right? But now we can do it internally. The arg command is the ones that allows you to pass values into the container, right? So when they go ahead and they say, hey, listen, I want to go ahead and do this, we can go ahead and we can pass arguments. And so that was like, hey, listen, when I do this, I can pass argument. And in this case, what are they doing here? They're going ahead and they're passing the argument. And so it's nice, it's easy to use, and it allows us to make these things a little more flexible. So we looked at some different ones: from, run, command, entry point, add, copy, and got a feel for those. So how is this actually happening in the background? Well, we know basically when we go ahead, we launch it on that base image, we start with that base image, and then basically every time we do a run or some of those other commands, it creates a new layer. All right, it creates a new layer, creates a new layer, creates a new layer, okay? And so when we start doing this, we're able to kind of build this kind of layered. And we'll talk a little bit about this process. The build context, all right, this is the directory. This is where all the files have to be. If they're not there, it's not going to work. All right. So building the Docker file, all right, some basic things here. We start with the base, all right. We can attach to it. So we connect to the base image, we attach to it, image, and we build our application. And the steps that we do to build that application, we add those steps into the Docker file. Okay. So basically every command that you typed inside that container to get your application running, you're going to do those same steps in the Docker file. When we think about this, one of the biggest things we try to do is come up with kind of a consistency. We want to keep kind of a standardized way to build. It makes it easier for your team. It makes it easier when you move to a continuous integration pipeline, reduces that build time. We want to keep our image size small, and we want to think a lot about security. One of the big things you want to use is a linter. If you've not used a linter, let me go ahead and show you what they look like. So a linter kind of checks the syntax. Okay. And there's different linters that are out there, okay? And so basically, there's some that are, but there's some that are online. Let's see if this one's online. And what you do is you paste your file in here, right? And you go ahead and you say, hey, run lintit. It'll go ahead, not only will it, tell you if there's errors, it also will give you recommendations. Okay. And so it's really kind of nice to use a linter before you go ahead and you're like, okay, I think I got it right. We can grab a sample file and simply paste it in here and see, okay, hey, how is it? Is it everything correct? And it just checks, make sure your syntax is right. Okay. Some of the other things here, notice they're using CentOS. I usually try to use something small. I like Minideb, I like Alpine, and a few other ones out there. Because what we want to do is be able to roll these out very, very easy. We commit our code, we want to automate the build process, we want to do testing on the containers, merge it into the staging, test on a production clone, and then we do a release. And there's different tools out there to go ahead and help us through this process. Docker files are a key component
of creating a good continuous integration environment. Thank you.